This is the lesson for valid arguments. I'll be doing one example for you. Alright, if you're going to determine whether a statement is valid or invalid, what you have to do is first translate the English words to symbols. So first in this section you must identify what you're saying P is and Q is. So I'm saying that P stands for I study and Q stands for I will pass math. If that's the case, then that first statement, if I study, then I will pass math, is translated to if P, then Q. The next statement, I didn't pass math. Well, that's the opposite of what we said Q was, so you would write not Q. When you see the word therefore, you're going to put a new conditional arrow. I didn't study. Well, that's the opposite of P. So instead of saying P here, you're going to say not P. All right, now you always, always, always group your first conditional in parentheses and insert a conjunction. It will always be a conjunction, and your statement is going to be this statement that you now need to prove using a truth table. So in the interest of time, I've already drawn that truth table here for us. And you see that it's that statement written in one line. P then Q, and not Q then not P. The beauty about the valid arguments is that it's always going to be 7 columns, and this second conditional will always be the final answer. So you're going to box and label that. When we number these, they're always going to number the same way. Remember, we complete everything on the left first. So this is column 1, column 2, column 3. Then not Q is column 4. The conjunction is column 5. You finished the left. Column 6 is just going to be the not P, and the final is going to be column 7. So to evaluate the final column 7, you look at the last two things, the thing you did on the left and the thing you did on the right. So that's going to be 5 and 6, always in this case. Now, how do I get 5? Well, again, you look on the opposite side of 5. What's the last thing you did on the left? Well, that'd be column 3. And what's the last thing you did on the right of column 5? Well, that's column 4. Okay, so again, we're going to use color to help us out here. All right, I'm going to start with black. I'm going to fill in column 1, which says P. Well, P is just true, true, false, false. Column 2 is Q, and Q says true, false, true, false. Column 3, time to switch colors, so we'll make it blue. That's a conditional. Remember the conditional song, true then false is false, all else is true. Well, this is false, making all of the rest true, because there were no other true then falses. Okay, come over here to column 4. Column 4 says not Q, so give me the opposite of column Q. So that's going to be false, true, false, true. Time to switch pens, so I'll make it red. And now we're going to evaluate column 5. Column 5 is our AND column, and remember the AND song. True and true is true, all else is false. Notice row 4 here is true and true, so this is going to be true. There are no other true and trues, so the rest of these are false. So you finished the left side, move over to the right side of the final. Column 6 says not P. So change column P to the opposite, and that would be false, false, true, true. And now the final. Remember the conditional song, true then false is false, all else is true. I'll change pen colors again, and recall that we're going to be looking at columns 5 and 6, the two red columns, to determine this conditional. You see there are no true then falses, so they're all true, no falses. The last step in the valid argument problem is to tell me, is this valid or invalid? Well, after you've created your truth table, when you look at the final column, if they're all true, it's valid. So this would be a valid argument. If even one of these would be false, you would say invalid. And that's how you do valid arguments.